All right, so do we have any questions that we can address?
I have one.
Yeah.
So when J1 and J2 are parallel, so J is the highest, and when they're anti-parallel, it's the smallest value, is it?
Right, that is the conjecture that we're making. We are going to prove that.
Could you please explain why is that, like anti-parallel and parallel, like a bit?
No, it's just like, suppose the only thing that we are assuming about these two systems, so we have system 1 and system 2, right?
Mm-hmm.
The only thing that we are assuming about this system is that they are J and the total angular momentum has a definite value. For system 1, it's J1 plus 1, right?
Mm-hmm.
So, we instead of writing the whole thing, we just write J1. And for system 2, it's J2 squared is J2 plus 1. And, you can put an H bar squared if you want to. It's up to you. So, depending on the units. So now, so if I were to, the thing is that we represent the angular momentum by, it's basically on some sort of a cone. Okay, so, okay, let me actually, so, so we don't even know what the orientation of this is, right? So this could be along the, along the z-axis. If it's mostly along the z-axis, even then we have some uncertainty, right? Because we don't know what the x and y is. So the fact that, I'm drawing a cone means, so this is the z direction, so this is the y direction, this is the x direction. So if the angular momentum is pointing in the positive z direction, then it must be, on this cone, right? On this upper cone. And so, classically, what would you, classical intuition is always very good. Classically, what would you say is that the first system could be, say, if it was a classical, spin or angular momentum, it was like that, right? So then that would be J. And then, if the J1 and the second system, suppose can be in many different configuration, right? It can be like this. But what if it is like this? When it's like this, that's when we expect, the total angular momentum to be the highest, the largest. So this is J2. But it could be that J1 is pointing in this direction and J2 is pointing in this direction. In that case, because they're pointing in opposite direction, depending on which one is greater, suppose J1 is greater than J2, then this is the angular momentum we would expect. So this is the classical expectation. So the quantum expectation would be something analogous. That's all I'm saying.
So it's similar to vector addition.
Yeah, exactly. Yeah. So it's a conjecture, but we'll see that it's a conjecture that is that is correct, and we'll prove it by explicit construction. Okay.
Okay, sir. Yeah.
Okay. Any more questions?